All right, the scale of the universe. Voyager Golden Record. 16 billion kilometers away flies a gold-plated copper disk with a voice saying, "Hello from the children of planet Earth." The disk is carried aboard Voyager 1, a spacecraft launched in 1977 that once sent back information about the planets of the outer solar system. The disk is filled with images and sounds of Earth. One day, aliens might find Voyager 1 and learn all about us. Discuss the Voyager record with a partner, then answer the question below. What images and sounds would you put on a recording for aliens? All right, so how do astronomers measure distances to the stars? Stars may look far away, but astronomers have found ways to measure their distances. Astronomers often use parallax to measure distances to nearby stars. Parallax is the apparent change in position of an object when you look at it from different places. Astronomers use the visible wavelengths of the electromagnetic spectrum to measure the parallax of nearby stars to determine their distances. All right, parallax of stars. The apparent movement of a star when seen from a different position is called parallax. Note that the diagram is not to scale. Okay? All right, so hold a finger about half an arm's length away from your face, as shown in the picture below, like this little guy. Switch back and forth between closing your left and right eye and watch how your finger appears to move against the background. Why does your finger seem to move? How is this related to the parallax of stars? All right, as shown in Figure 1, astronomers look at a nearby star when Earth is on one side of the sun. Then they look at the same star again 6 months later when Earth is on the opposite side of the sun. Astronomers measure how much the nearby star appears to move against a background of stars that are much farther away. They can then use this measurement to calculate the distance to the nearby star. The less the nearby star appears to move, the farther away it is. Astronomers can use parallax to measure distances up to a few hundred light years from Earth. The parallax of any star that is farther away is too small to measure accurately. How do astronomers describe the scale of the universe? Astronomers define the universe as all of space and everything in it. The universe is enormous. Astronomers study objects as close as the moon and as far away as quasars. They study huge objects such as clusters of galaxies and tiny particles such as atoms and stars. Astronomers frequently use scientific notation and a unit called the light year to describe and measure distances and sizes in the universe. All right, the light year. Light years are often used to measure large distances and sizes in the universe. In space, light travels at a speed of about 300 million meters per second. A light year is the distance that light travels in 1 year, about 9.46 trillion kilometers. The nearest known galaxy to the Sun is 25,000 light years away. Some galaxies are many thousands of light years across. The light year is a unit of distance, not time. For example, if you bicycle at 10 kilometers per hour, it would take you 1 hour to go to a mall 10 kilometers away. You could say that the distance to the mall is 1 bicycle hour. Once you get to the mall, it takes you 1/2 hour to bicycle around it all the same speed. Therefore, you could say that the size of the mall is 0.5 bicycle hour. All right, scientific notation. Scientific notation uses powers of 10 to write very large or very small numbers in shorter form. Each number is written as the product of a number between 1 and 10 and a power of 10. For example, 1,200 is written as 1.2 times 10 to the third. 1 light year is about, that is hundreds, thousands, millions, billions, trillions, gazillions. So 1 light year is about 9,460 trillion meters. To express this number in scientific notation, first insert a decimal point in the original number so that you have a number between 1 and 10. In this case, the rounded number is 9.5. To determine the power of 10, count the number of places that the decimal point moved. Since there are 15 digits after the first digit in scientific notation, this number can now be written as 9.5 times 10 to the 15 meters. All right, the immensity of space. Objects in the universe vary greatly in their distance from Earth. To understand the scale of these distances, imagine yourself on a journey through the universe. Refer to Figure 2 as you take your trip. Start on Earth. Now move right and change the scale by 100 trillion or 10 to the 11th. You're now close to the Sun, which is 1.5 times 10 to the 11th meters away. As you move right, the distance increases. The nearest star to us, our Sun, Proxima Centauri, is about 4.2 times 10 to the 16th meters, or 4.3 light years away. The Sun is many thousands of times closer to Earth than Proxima Centauri. Moving farther right, the Andromeda Galaxy is about 2.4 times 10 to the 22nd meters away. All right, so over here, do the math. To express a number in scientific notation, first insert a decimal point in the original number so you have a number between 1 and 10. Then count the number of places that the decimal point moved. That gives you the power of 10. All right, the Sun takes 220 million years to revolve once around the center of the galaxy. Express this length of time in scientific notation. All right, then calculate. The distant star Deneb is thought by some astronomers to be 3,230 light years away. Write this distance in scientific notation. All right, then up here, explain why astronomers use scientific notation to describe sizes. All right, scale of the universe. Scientists often use scientific notation to help describe the vast distances in space. The Sun is 1.5 times 10 to the 11th meters away from Earth, but the next star, Proxima Centauri, is 4.2 times 10 to the 16th meters away, almost 300,000 times as far. So, express the distances to the Sun and Proxima Centauri in meters by writing out all the zeros in the number. All right, review. What is a light year? And how are light years used to measure distances and sizes in the universe? And how do you know that the Sun is many thousands of times closer to Earth than any other star?